So continuing on with our discussion about using maps. So what we're going to do now is use the remove method to remove a specific key from a map. And to use it, it's probably, as you're thinking now, the way to remove it is logical. There's actually two ways of doing it. So the first way we can do it is we can do something like, and what we'll do is we'll leave the printout down the bottom there so we can confirm that our changes have actually worked. So down here we can put languages.remove. We can put Lisp, and that's going to remove that. That's going to remove the Lisp entry. But we can also do something else. We can remove a key only if it's mapped to a certain value. So for example, we could do something like this. We can put if languages.remove algol and put a family of algorithmic languages. Algol removed. What's the typo there? I can put something like else. Algol not removed. Key value pair not found. So if we now run this code again. So we can see now from our list, first we got this message that algol not removed, key value pair not found, but you can see that Lisp has been successfully removed. So just confirming again that on line 34, we're checking to see whether algol, the key algol, and also the value of a family of algorithmic languages was there and only removed it under those circumstances. And obviously on line 21, when we define it, we didn't actually define it like that. And as a result, it didn't remove it for that reason. Now, the other thing to note is that the remove method does return true or false. That's good to know. If you do want to check that something was removed, you could actually put an if then and just check for true or false to indicate if the key existed in the map and it was removed. And you can see that that on line 34, because we used that functionality because we did an if languages.remove and passed the parameter, and obviously that returned true, and then we're able to use that in our if then else. And just to confirm that works, if I go back here now and copy the original definition from line 21 and paste it into here on line 34 in the second parameter, and if we run this time you can see we've got the message algol was removed, and we've now only got 3 items left. Both Lisp and algol got removed from our list of languages. Okay, so let's just clean up a few things because I want to talk now about a few other methods. So what I'm going to do first is I'm going to comment out this removal of Lisp. And then down here, just before our for loop, what we're going to do is print out a message here, we're going to use the .replace method. And what replace does, it's used to replace the entry for a specified key if it's already mapped to a value. So to see what I mean by that, we can do something along the lines of here, and we'll print out the results. Languages.replace Lisp. We'll do something like a functional programming language with imperative features. The first one, but also we'll add another entry as well just to show you, confirm the results we get out of this. And we'll do something like system.println languages.replace, and we'll try scalar. This will not be added, obviously, because scalar doesn't exist, and we're replacing on the assumption that the key already exists. So if we run this, so you can see what's happened. We've got therein lies madness. When the first one replaced on line 43, when that code was executed, it returned the previous entry, which of course was therein lies madness, which we configured on line 23. The next entry there returned null, which was its way of saying it didn't already exist on file. And it's not added, as you can see, because it doesn't come up with a list there because it wasn't already in existence in the map. So it doesn't get added, unlike a put, which does that and then replaces it if it's already there. And just like remove, we can also specify the existing value so that a mapping is only updated if the key was mapped to the old value we did, that we originally specified, or that we can specify. To do this, we provide the expected old value before the new one. Now what we'll do is we'll just do it wrong the first time, just so you've got an idea on what I mean. So on this line here, instead of just printing it out, we'll change this code a little bit. We'll put an if there. If languages.replace, Lisp, and notice how it's binding there's three options there. There's key, string old value, and string new value, or we can just do as we did in the past. So in this case, if we put something like the old value of this will not work, and specify the new value like so, Lisp replaced, else Lisp was not replaced. Okay, and I'll just comment out the scalar one for now. So if we run that, we should find it doesn't get replaced. So Lisp was not replaced, and Lisp is therein lies madness. It's still set to the original value, which of course we configured on line 23. So again, just as a recap on that particular function, so what we're doing is we're passing a third parameter, we're passing the key, we're passing what the old value was, and we're passing what the new value was. So that's just a way for you to check that you're really only updating if the value, this particular value already existed. And just to confirm that, we can come back up to here and copy that. And change this will not work. Paste that in there like so. Then we run it. We can see that Lisp was replaced, and Lisp is now a functional programming language with imperative features. So it's obviously worked through and updated, which is what we wanted to do. Now you might be wondering, well, why is that useful? Well, one good use for it would be, say, for example, if you're updating someone's name after they got married, you could ensure that the correct person is updated, or if changing an address. So you're just checking to make sure that that exact entry, you're at that exact right entry before you update it, so there's no chance of accidentally overwriting the wrong information. Now for these examples of the methods defined by the map interface, we've used a map that uses a string type for both the key and the value. Now, in fact, both the key and the values can be any object. We could even use a map type as the values in another map. In actual fact, you could add a map as a value to itself, although it's probably not a good idea to do that. It's important to point out that unlike other languages, such as Python, for example, there's no requirement that the keys of a map be immutable. And just as a recap, immutable objects are things like strings and integers whose value can't change. Now, if that sounds strange, when we assign a new string value to a string variable, what we're doing is we're changing the value that the variable holds. We're not changing the string. So our goal, for example, that we used for one of the keys earlier, it's on line 21, can't be changed. On the other hand, an array list can change by having new items added or new values assigned to existing entries. Now, with that said, the Java documentation does warn that great care must be exercised if immutable objects are used as map keys. So they give you that warning, but they're not prohibited. Now, the reason for the warning is that a map object can behave unpredictably if the key objects change in such a way that equals comparisons are affected. Remember, we talked about those equal comparisons in the last video, and actually earlier in this video. So it's worth being aware of this warning, but you'll probably have to do something fairly advanced before it affects you. So using classes as keys is in itself fairly advanced. Now, one thing that's not permitted is for a map to contain itself as a key. And it would be a very bizarre program that attempted to do such a thing. Now, to demonstrate some probably more interesting uses of maps, what I'm going to do is model a small part of the original adventure game, Colossal Cave, which allows a player to move around the various locations by typing in compass directions. So what we're going to do is create a new project. We're going to call that adventure, and then we're going to create a new class. So let's go ahead and do that. So file, new, project. I'm just going to choose the standard things that you've probably seen me do a million times now. We're just going to create the project from template, and we're going to call this one adventure. Finish it. And we're going to say this window, which will close off the other code because we don't need that for now. I'm going to move this over a little bit to give us a bit more space. And we're going to go ahead in the package, and we're going to create a new class, and we're going to call that location. Like so. So let's start by defining some basic information about this location. And again, this is the location in an adventure game based on the original Colossal Cave adventure, which is one of the first adventure games that came out years and years ago. And feel free to Google that if you want to find out more information about that. So let's start. We're going to need a location ID first. We're going to have a private final int location ID. Let's also have a description. So private final string description. This is the description of the location. And we're getting that error most likely because of They haven't been initialized, which you can see there, but we're going to initialize those in a constructor shortly. We also want our map, which is going to be a map of exits. So private final map string integer, and we'll call that exits like so. And we'll use a Java util map. Let's add a constructor. And the constructor is going to take just the two parameters. So we're going to take the location ID and the description. We're not going to do the exits because we're going to initialize that. So we're going to do that. And you notice those two arrows have gone away now because we've initialized it. And let's set our exits up. This.exits equals, we'll just initialize it to a new hash map, like so. Then what we want to do is add a couple of methods. We want to add the ability to add an exit to our location. We want to get it for the location, get it for a description, then we want to get it also for our list of exits. So let's go ahead and do that as well. So getters are going to be easy enough. Let's add those first. Getters. We want location, the description, and the exits all as getters, so we can get access to those from another class. And actually, let's put it up here. So what we want to do is we want to add the ability to add an exit. So to do that, we're going to do public void public add exit. And we'll do string direction. And be int location. Then we'll put exits.put, and our direction is going to be the key, and the location is going to be our value. So that's a very basic location, and so it's containing, just to recap, the location contains a location ID and a description, as well as a map that we defined on line 12, which is used to store the available exits from the location. And we've added a method to allow directions to be added to this map so that we can define the details from the main program. Now, one thing about this class is that we're programming defensively. What I mean by that is that anything that doesn't need to be exposed to the outside isn't exposed. And our fields are marked final so that they can't be changed once the constructor has finished creating a location instance. So one useful technique that we've used is in the getter for the exits map. And with the get exits, what I did with it there, I actually need to change it. I want to show you what I'm going to do there, then I'll explain why I'm doing this. So what we're going to do there is we're going to return new hash map of exits. I'm putting exits in the constructor. So the reason that we're doing that is that instead of just returning the exits map, I'm creating a new hash map and passing our exits in the constructor, as you can see there on line 32. Now we've seen that use of the constructor before with lists, and it does the same thing here. So in other words, a new map is created that has all the mappings from the exits map. Now the reasons that this would be useful, a useful technique, doing that here, is that nothing outside of our class can change exits. So the getter returns a copy of exits, so that if the calling program wants to add or remove mappings from it, then the exits mapping field won't be affected. That's really important there. So although we won't be using the location class as a key in the map, we'll use it later to show some ways to make your classes immutable, and returning mutable objects from a getter in this way is one of the techniques here to make sure that that works. So let's go back to our main method and write some code to add some locations. And what I'm going to do is start by putting a scanner in there. Scanner equals new scanner system.in. We'll just accept that input. And what I'm going to do is I'm going to copy and paste some of these locations just to save a bit of time. We're going to have 6 locations to start with. These are going to be locations in the game. And I also need to define the map here. So it's going to be private static map. It's going to be integer location being our class. I'm going to accept the import I should say. We'll call it locations equals new hash map, like so. That's initializing, and then obviously from lines 13 through 18, we're adding new locations. You can see we're adding a number. We're putting the original key there, which is the integer 0, 1, 2, 3, 4, 5, which gets converted to an integer object via auto boxing. And then you can see that we're creating a new location object using the same technique. We're passing the number, which is going to be sort of our location ID, then a description of what the particular location is all about. So let's now add some code that allows us to type in a number and then prints the location description that it's retrieving from the map. So to do that, we're going to do something like this. We're going to put int like equals 1. We'll put while true. We'll system.out. We're going to do locations.get lock.getDescription. So we're going to get the description of the current room. And then we're going to put if lock is equal to 0. We're going to break out of this while. Otherwise, we're going to do lock equals scanner dot next int. Retrieve the number. Then we're going to put if not locations dot contains key lock. I'm going to print out a message. You cannot go in that direction. So we just run this, and then what we'll have to do is finish this video and wait for the next one to continue running the code. But you can see we started out because we defined location to be equal to 1. The default room is going to be that object. So we're going to put something like, we know that the second location 2, is you're on top of a hill. So we're going to there and I type 2, you're on top of a hill. If I type in 3, you should be inside a building. 5, you're in the forest. And 4, let's try the other one as well, you're in a valley. And if I type 0, you're sitting in front of a computer learning Java, which was the exit, or the way to sort of break out of it. So that's a very simple program there. Now in the next video, what we're going to do is we're going to enhance this and we're going to build the exits. So we're going to set it up so that when you're at a particular location, you've got a list of exits and you can only use those exits that are valid for that particular location. So let's look at doing that in the next video.